Hi everyone, in this video we shall see the topic simplex method. Simplex method, the linear programming with two variables can be solved graphically, but the graphical method has limited application in the business problem as the number of variables is substantially large. If the linear programming problem has larger number of variables, then the suitable method for solving is the simplex method. The simplex method is an iterative process through which it reaches ultimately to a minimum or maximum value of the objective function. The simplex method also helps the decision maker or the manager to identify the following: redundant constraints, multiple solutions, unbounded solution, infeasible problem. Now let us solve a problem using simplex method. The problem is maximize z equal to 3x1 plus 2x2 plus 5x3 subject to the constraints x1 plus 4x2 less than or equal to 420, 3x1 plus 2x3 less than or equal to 460, x1 plus 2x2 plus x3 less than or equal to 430, and x1, x2, x3 are positive or non-negative. Now let us move to the problem. Since we have all the inequalities less than or equal to, we have to introduce the slack variables for each constraints. Those are S1, S2 and S3. Now the standard form of the problem is maximize z equal to 3x1 plus 2x2 plus 5x3 plus 0s1 plus 0s2 plus 0s3 subject to the constraints x1 plus 4x2 plus s1 equal to 420. Now by introducing the slack variable, the inequality becomes an equality. Second constraint is 3x1 plus 2x3 plus s2 equal to 460, and the next one is x1 plus 2x2 plus x3 plus s3 equal to 430, and x1 plus and x1, x2, x3 are greater than or equal to 0. Now let us move to the initial iteration. Cj corresponds to the coefficients of each variables of the z function. Those are 3, 2, 5, 0, 0, 0. That is 3 is the coefficient of x1, 2 is the coefficient of the variable x2, 5 is the coefficient of the variable x3. Similarly, 0 is the coefficient of the variable s1, s2, s3. Now CB, that is the vertical values, those are the values, that is those are the coefficients of the variables s1, s2, s3. YB corresponds to the function s1, s2, s3, those are written vertically. Now we are seeing the vertical values. XB means the coefficient, that is the constant values on the RHS of the constraints. Then this is the remaining are the interior matrix, that is 1, 4, 0, 1, 0, 0, coefficients of the first constraint. Second constraint coefficients are 3, 0, 2, 0, 1, 0. Next constraint coefficients are 1, 2, 1, 0, 0, 1. Next we have to find Zj minus Cj values. Those are minus 3, minus 2, minus 5, 0, 0, 0. Now we have to check whether all the values are non-negative. But we have negative values. It means the current basic feasible solution is not optimal. So next we have to move to the next iteration. Before that we have to find the theta value. That is the ratio of the xp value together with, that is it should be divided by the x3 values, corresponding x3 value, vertical value. That is, first we have to find the leaving variable, that is the most negative value which corresponds to x3. So here this is the pivot column, and so we are dividing 460 by 2, that is the first ratio theta, which is equal to 230. Next one is 430 by 1, which is equal to 430. So among this we have to choose the smallest value, that is 230. So from this we have determined the pivot element as 2. Now let us move to first iteration. The procedures are same. Previously the leaving variable was s2, so we have replaced s2 by the entering element x3 in this table. The rest of the values are same, and the interior matrix, those are found by using the formula. That is, we have a formula to find the matrices. That is, the aim is to convert the pivot element as 1 and the remaining vertical values to be 0. So now again by the procedure we have determined the Zj minus Cj values, those are minus 3, minus 2, minus 5, 0, 0, 0. Again we are checking whether the values are non-negative. Here we have negative values. It means the current basic feasible solution is not optimal. So again we are finding the most negative value. That will be the pivot column. Similarly we have to find the ratio and choose the smallest value. From that, here also the pivot element has been found as 2. Again next we have to move to second iteration. By following the same procedure, see the Zj minus Cj values all are positive, all are non-negative. It means the current basic feasible solution is optimal. Now we have maximum Z equal to 1350, that is the Zj minus Cj value corresponding to xb. Next x1 value is, there is no x1 value in the basis, so we have 0. x2 value is 100 and similarly x3 value is 230. This is the required answer. Thank you.